The second two-dimensional problem we're going to do involves the terms angles of elevation and depression. Okay, we want to work out the height of a vertical tower. Sorry, I see that hasn't printed nicely. Vertical tower DC. From B, the angle of elevation of the top of the tower is x. All that means is that your angle from the horizontal up to the top of the tower is going to be x. That's your angle of elevation. There are a couple of terms we need, and in course when we talk about an angle of depression, which comes next, the angle of depression of A from D. Remember, at D you measure your angle of depression from the horizontal. So from D you're looking down at A. The angle through which you look is y. And of course your horizontal lines are always parallel to each other. So if that angle there is y, so is the angle at A. Really important that you remember angles of elevation and depression are always measured from the horizontal. Now in this case we asked to prove that expression. We asked to prove that DC is equal to D sine x sine y over sine of y minus x. Identify what you want and where it's going to be. We want the height. In maths, when we talk about height, we always mean perpendicular height, so that angle there is going to be 90 degrees. What do I want? I want DC, which means I would have to work in triangle DCB. Looking at that triangle, I know the angles in that triangle, but I don't know any lengths. And so before I can work in that triangle, I have to work out another length. And the only one that we can work out is BD. Because BD is common to another triangle, ABD. So identify what you want. Which triangle does that use? What do I need to be able to work in that triangle BD? So I'm going to start in triangle ABD. All right, so in triangle ABD, I look to see what I've got. Now, this angle over here is y. I beg your pardon, they also told us the distance between A and B is D. I should have filled that in. Now, this angle is x, and so is that whole angle up there. This whole angle here is also x. And so the angle that I'm actually interested in working in is this little piece over here. And that angle there is going to be x minus y. In triangle ABD, I've got this pair, a side and its opposite angle, and therefore I can use the sine rule. I'm going to put the thing I want on top. So in triangle ABD, I'm going to start off by saying that BD over sine of the opposite angle must equal D over sine of the opposite angle. Multiplying to isolate my BD, BD becomes D times sine of y all over sine of x minus y. I've fulfilled that part of my plan. So now I can move on to working in the other triangle. So now I'm in triangle DCB. In triangle DCB, that happens to be a right angle triangle. Now you can use the sine rule if you want to, but it's actually much easier to say, right, I'm going to work with angle x. What am I looking for? My opposite. What have I got? My hypotenuse. So I'm going to say that sine of angle x is my opposite, the thing I'm trying to find, over my hypotenuse BD. Do a little bit of algebra here. Multiply both sides by BD. So I can say that BD times by sine of x is equal to DC. At this point, once you've done all the simplifying you can, you're going to replace the BD with the expression that you calculated over there. So I'm just going to write the DC on this side. DC is equal to BD, which happens to be d sine y, all over sine of x minus y, multiplied by sine x. And lucky for us, our answer is exactly what we were trying to prove. Now, very often they will give you numerical values and ask you to calculate the answer. In this case, I'm saying to you, what would DC be if little d was 20, x was equal to 74, and y was equal to 56? Okay, all you're going to do is replace. DC would equal 20 multiplied by sine of my y value multiplied by sine of my x value all over sine of my x value minus my y value. And now it simply becomes a matter of typing all that into your calculator. 20 sine of 56, sine of 74, all over sine of brackets 74 minus 56, and that answer becomes 51, 58 if we round off correct to 2 decimal places. And now I gave you units of measurements, so our answer is going to be 51,58 meters. Okay, thank you.